There we go. Thanks. All right, so tonight we're talking about testing and testing on the back end. And the code that you'll be writing in the work that you do is going to be code that other people are be looking at and have access to, and potentially have a need to change. It depends on the environment that you're working in. Some people open source contribution model even within their own system, which basically means you might have written that piece, but if I needed to do something different, then in order to support what I'm doing, then I should have the right or the ability to change it. And there's some benefits to that kind of a model, but there's also some drawbacks, right? So for example, things that you did to make the thing work a certain way could be broken. Maybe the other engineer that's working on it, or a software developer that's working on it, doesn't understand exactly all the ins and outs of what it should take to keep that piece of software working properly. And so they could accidentally break it without really knowing it. So the kind of testing that we're going to look at tonight is the kind of testing that's meant to provide early feedback about the quality of your overall system. When we consider testing as a topic, there are a lot of different kinds of tests. One of the things that I say often is that among all the features that you provide in whatever software it is you're developing, the most important one, and the one people are going to appreciate the most, is reliability. And because of that, you want to take the effort and the time to add checks to your code to ensure that it's being tested properly, so that you've got good confidence in the quality. If you look here, and I'll drop this in Slack, this is a link to a website that's got a diagram on it. Here they're calling it the Agile Testing Matrix. I've seen it called the Agile Testing Framework. It's been around for a while, but it provides a pretty good handle on trying to understand the breadth of the kinds of testing that you can use to validate the quality of your code and your product. It's a quadrant system that starts in the lower left-hand corner. Over here, the horizontal scale talks about guided development versus critique of the product, and then up and down there's technology facing and business facing. I wouldn't really focus too much on that, other than just to say that there are really four basic kinds of testing that you'll encounter and have to consider. There's unit testing components. As it says here, these are code level tests. And these are tests that are meant to test a small portion or a small unit of functionality within your application. We're going to take a pretty good look at writing unit tests tonight. Above that, you'll have tests that I call functional or component type tests. Here they have the word component here. But up here is where you're really testing collections of API calls and function calls that perform a piece of functionality that a user could put a name to. So you're not testing individual methods or functions or classes, but you're testing features applications. So they're feature level, functional level, or component level testing. Over here in this quadrant, you have tests that are more end-to-end. So while you may have multiple applications that perform different functions, but together they work together to create whatever value it is that your system is meant to provide. And that's where you do this kind of testing. Your end-to-end testing will typically happen here. It happens less frequently, but it's more intensive. And this is where you can also provide visibility to the end user and get their input on that. Beta testing might fit into this category as well, alpha and beta testing. Depending on what kind of product it is, you may also encounter something called I just lost the name of it because I had a bunch of other stuff run through my mind. I was thinking blue, green, and canary, but A/B testing is another kind of testing that you can encounter where you roll out new functionality to just a certain number of people. That's where you're really testing the overall system. And then down here in this quadrant is where there are tests that I call non-functional tests, right? So those where you're testing security, performance, scalability, the ability for the application to grow in its capacity as well as shrink properly in its capacity. Nowadays, as you deploy things to virtual environments that are like computing as a utility, like Amazon or Google Cloud, AWS or Google Cloud, Azure, Heroku, and others, you want to make sure that what you're paying for is right-sized to the need. And so not only does your application need to have the ability to automatically expand to meet the needs of the demand, but it also should be able to shrink properly. And those are kinds of things that you want to test here. Okay, so this is just giving you kind of a peek to the there are people that make entire careers out of being experts on all of these kinds of testing to bring a quality approach to a product. Okay, let's see. Well, someone says you're only seeing my Slack. I apologize. I thought I was sharing the right thing. Give me just a second. That is a total rookie mistake. Okay, about that, guys. Hopefully you can see this now. I did post the link, so I don't know if some of you were following along, but this is where I was saying that unit level or small functionality, functional component testing up here in the upper right is where you get end-to-end and system level testing. Integration testing would fit up here as well. And then down here is where you have non-functional performance, load, security, scalability, and those types of tests that show up here. I apologize for the lameness there. All right. Yeah, now that you can see it, I'm going to stop talking about it. So, but you have the link, so feel free to kind of check that out, and you can find more information about it. It also talks about something called test-driven development, which we're going to talk a little bit more about tonight. Okay, all right. So we've talked about unit testing. We're going to dive right into some code. So if you have forked the repo to your own account and cloned it to your local machine, let's see. I want to hopefully that's large enough for you to see it there. All right, so just to kind of go through the guided project a little bit, we're going to come back to a lot of this because I kind of want to start with something that's not actually in the guided project, but we'll use it as a framework to get a little bit of a look at unit testing. So in this project, it's pretty straightforward. You can see we're going to be using .env, or we could be using .env. We'll talk about that later as we get to it. You'll see we're bringing the server in from the server file and listening. The server file is up here. Here's where we're getting Express and doing the normal thing we do there. We have 2 endpoints here, hobbits and slash. And our database model is here. In our data, we've got dvconfig, which is using Connects file, and it's also got this where we're using the environment to configure Connects. We're going to come back to that and talk a little bit about that in a little bit. And for the most part, that's pretty much it. We look at the Connects file, and we're going to dive into this in just a little bit. You'll notice that we have 2 different sections here. In the past, when we talked about data modeling and so forth, we the default version of the Connects file when we did the Connects init had a number of different sections here, and we deleted all of them except for development. And tonight we actually have 2 different sections, and it turns out that that could be important here. One to detect data structure. Okay. Let's see. Under hobbits, here's where we've got our model, which is, you can see it's got some functions that don't really do a whole bunch. We're going to come back to that as well. So it just gives you kind of a brief overview of what we have. Let me pull this thing off of here. There we go. All right, but before we get into that, what I want to do, and you're welcome to follow along with this, and I'm going to post some of this code in Slack so that you can save some typing, because we're really just wanting to focus on some of the principles here. is I'm going to add a file here to the root called calculator.js. Okay, this is kind of a common use case that's used to demonstrate or to get a handle on understanding unit testing, because the subject matter of the code is very simple, but it gives you, a really clear idea of what we're doing. So let's say that in our calculator we have a function that's called add. It takes two numbers and it just returns them added together. Okay, and then we'll export that. Okay, so it's a real simple calculator. Any application that needs to can bring it in and use it. But what we want to do is write a test that ensures that this function always does what it's supposed to do. Okay, and again, we're keeping this purposely very, very simple so that we can focus more on writing the test than on the code itself. So I'm going to open up a terminal here. So somebody's asking which repo this came from, and it came from one. It's called Node Server Testing Challenge, or Node Server Testing Guided. I can get that out of the TK, but I'll post it here as well for you. Yeah, I apologize if you got WebAuth 4 in preparation. The link that's in the TK is the one that we are always going to use, so you want to go and grab that. Shouldn't take you long to fork it and clone it, but that's the one that we're going to be working from tonight. I'm going to be giving some breaks tonight, some more pauses as we go, to give you guys a chance to catch up, so you'll have an opportunity to catch up if you're a little behind because of that. All right, so the idea here is that we want to add a test that makes it so that if anybody comes in and changes, maybe they've got a fancier way to add numbers, who knows what, they don't break our code, that it does exactly what's expected to do. And really, this kind of testing kind of takes a black box approach, in that we're not really so concerned about what happens inside the function. We're just concerned that we can pass in what needs to be passed in and receive what we're expecting. So that's kind of the approach that we're going to be taking to this with our testing. And so in order to do this, we're going to use a framework, a unit testing framework called Jest, J-E-S-T. It's a framework that was created by the folks at Facebook. And we'll take a look at the documentation here in just a little bit. But what we want to do first is add it. So first I'm going to just run yarn to bring down all of my dependencies. And then after they come down, I will add Jest to the package. But while these are downloading, I'm going to come over and just look at the documentation. Okay, documentation is at jestjs.io. I'll put that in. In Slack, so you can have access to that. As it says, it's delightful JavaScript testing. Sure, okay, we'll consider it to be delightful. And there's an API section here that tells you about the methods that you can use. We're going to go over what some of these are, and then over here on the left-hand side, down here, you'll see a configuring Jest section, and we'll come back to that in a little bit to take a peek at a kind of an important element of configuring Jest. Okay, so it looks like I've got all my dependencies down. So now I'm going to add to my development environment the Jest package. And that'll make it so that I can create tests. So while that's doing that, I'll come back over to the documentation. And if we go to the configuring Jest section, I'll clearly not so that and I'm going to come down here to this list of options, and you'll see one called test match. okay? And it's an array of strings. And what this is to do is to allow you to specify to Jest where it can find your tests, okay? So the key principle here is that with unit testing, you actually write code to test your code. Okay, so that our tests are actually just JavaScript files that are functions that can call our code and validate that it's doing the right thing. And if that makes you think, well, how do we know that the code that is our tests is accurate? It's a valid concern. And one of the reasons why you want to use a well-baked framework so that you can more easily validate that your tests are accurate by looking at it. In addition to that, there's some, instead of by running other things to test your tests, in addition to that, there's some pretty key principles that you want to follow. We're going to just touch on them lightly tonight, but as you learn more about the topic, you'll find a lot of philosophies and people that have some good experience that can explain, how to be most successful when it comes to unit testing. One of those is that your unit tests, each of them, should be so simple that they only test one thing. You don't want to combine a bunch of different things into a single test. That just complicates the test. It makes it more likely to have bugs, and you want to keep them extremely simple. And then secondly, you want your tests to have as few dependencies as possible. We're going to kind of break that rule tonight, in that you'll see that some of the tests we'll write before the end of the night actually will use a database. For the most part, whether it's a database or a network or an API that's running on another server or any other service that's running elsewhere, rather than depending even on a test version of those things to run your tests, you want to try to find a way to mock them. There are some cases where you will have exceptions. I've seen tests that use databases. It just is far more convenient to do that, and the risks are worth it. But it does introduce something that can halt your production deploys and give false positives with respect to bugs. Because if your test depends on a database in order to bring data in to use as part of the test, and the database is down, then the test will fail. And what that failed test will indicate is that there's a problem with your code. But in fact, there's not a problem in your code. It hides the fact whether or not there's a problem in your code. If there was really a problem in your code, you couldn't really be confident of that. And so the more dependencies you have on outside services, the more complicated your testing code gets and the more likely you are to have bugs in it. So the key to successful unit testing is to keep them as simple as possible, as small as possible, and to reduce dependencies. So that's the best way to ensure accuracy among your tests. So our tests are going to live in code files, and what this test match option does for Jest is it allows us to tell Jest where it can find the code files that contain our tests, as opposed to the code files that contain the code that's being tested. And by default, you can see it's got a regex, a collection of arrays here. And essentially what this says, and what we're going to use, what I'm going to use is putting some of my tests in a directory called __tests __. So that's one place it will look. It'll also look for any test file or any JavaScript file that has or type file. So you can see here as part of this regex, but it'll take a .js or a .ts that has the string spec or the string test somewhere in the file name. Right, so we can use that to ensure that when we run the framework that executes our tests, it's able to find the code files that contain our tests, okay? So because this is the default, we don't have to do anything. I'm just gonna use the as here, it's looking for .js, .jsx, TS, and TSX files inside of tests folders, as well as any files that have .test or .spec somewhere in the file name, right? So what I'm actually going to do both of those. So if I were to come back over to my code, here I'm just going to create a folder. Okay, and I'm going to call it __tests __. Some of you are likely curious to know where these icons come from. I have a plugin that does icons. I can tell you which one it is. I'll put that in my notes so you can get it later, but there are many of them that just do icons that are kind of fancy. And this particular plugin detects that this folder is supposed to contain tests, which is why there's a test tube on it, okay? And inside here, I'm gonna create a file. I'm just gonna call it calc.test.js, okay? So this is where I'm gonna put the code that executes my tests, or that are my tests. Now, what's going to happen is we're going to use Jest to execute our code, our test code, and Jest works a lot like NodeMon, for example, right? So Jest is an environment or an application that when you run it, it'll go through and find our code, load our code into its environment and execute it. Because of that, we don't have to do any kind of a require to import Jest into this environment. It's going to take our code and put it into its own environment, and we'll have access to everything that's in its environment. So if we were to go back to the documentation, for example, and we look at all the methods here, these are all going to be available to our test code, and we don't have to import anything for that to be the case. Because it's a test file that Jest is going to find, Jest will execute it and in its own environment, and it'll provide access to all the different methods that we want to have in order to actually run tests, okay? Now, in addition to that, you'll see that the basic thing that you're going to use is this test method. You can see that it takes a name, which is just a name of the test, a function, it's a callback function that it will execute, and then a timeout value that allows the test to end if the function doesn't return in a certain period of time. This timeout value turns out to be optional. So if we click on it, you'll see that the very first thing it says is it's also under the alias it. One of the things you'll find in different testing frameworks is that sometimes they try to name things so that the test itself reads almost like an English sentence, so that it's easy to tell just by looking at it what it's supposed to do, right? So you see here, for example, we can use the word test. The name of it is did not rain. And then there's an arrow function, which is a callback. And then inside that, it's going to call another method called expect, right? The expect thing is what's called a matcher, okay? And there's a number of different versions of that we'll use just a few of those tonight. And so one of the things that we can do is we can say, you know, expect a certain value or expect a certain variable to have a certain value and so forth. So we're not going to dive super deep into the syntax. Know that it's documented here, and I'll give you a brief introduction to it, okay? Let's see. Yeah, there's no editing to so someone asked the question, do we need to edit package.json? And we don't, because it came pre-edited. We are going to cover what's in package.json in a little bit, but for now we don't have to worry about it. Okay, and we're not actually using it right, the stuff that's in there right now. Okay, so we'll come back to that one. And someone else is asking about supertest. We're going to come back to that. We don't need that currently, and I'll talk about what supertest is and what it does. Right now, we're only using Jest. Okay, so all Jest is a framework that will find and run our tests, and that's all we needed to do for now. So what I can do is put test, and then the name of my test, and then a callback. Okay, so actually what I could do here is I could put, let's say, let value A equals 2, let value B equals 2, let expected result equals 4, let the actual result equal Okay, so this is one of those expected matchers that we can use. We're going to expect the result to be the expected result. Okay, now in order for this to work, obviously I have to be able to call later dot, which means I need to bring it in. So okay, so there's my test file, and I've saved it in my tests folder. Okay. Now in order to execute this, I could just, oh, I don't have it installed globally, I only installed it locally, so I have to use npx jest. And what this is going to do is going to go through and find any of the tests that match that default regex that we were talking about, and then try to execute those tests. Okay. Now, what you found here is that it found 3 different test files. It found one under Hobbits, and the reason why it matches is because it has this .spec in the middle of the name. It found another one under API. These are test files that I didn't create. They came along with the repo. But because it found both of those, it tried to run the tests in them, but they're both empty, right? So if I look at this API file, you can see that there's nothing here, okay? And likewise, if I go and look at, where's the other one under server, yeah, that was the server. The other one's under Hobbits, right? So here, and they're just both empty. So I could, maybe one thing that I could do is just do a test. We'll expect true to be true. Okay, so this is just a useless test that will just allow me to get Jest to be quiet about these 2 files. It'll still run them, but they'll be successful. So if I were to save those and then run Jest again, oh, npx jest, you can see it's running all 3 of these test files, and then all 3 of them passed. Okay, and it tells me how many test suites there were. We can see how many of them passed and so forth. Okay, so again, all Jest is doing is walking my directory and looking for things that match that test match property, which by default is that regex that matches anything in this folder and anything that has .test or .spec in the file name that ends in a .js or .ts, but we're not using TypeScript. So, and it's finding 3 of those, and it's executing all of those tests, and we can see that we're passing. Okay. Let's see. No additional questions. We'll give you guys. So what I actually want to do is I am going to post some code for this calculator, and I want to invite you to, I'm going to put this in Slack here. Okay, it's real simple. It just has an add. Actually, sorry, let me change that. Give me just a second. I was doing something else, and you don't want to have this. So give me just a minute. Okay. All right. So you want to use that and save that to a calculator.js file, and then create a testing file that will test each of those functions. Okay. And we'll give you, we'll start with 5 minutes. Keep your own eye on the clock. I want to leave my code up here so that everyone can follow it. And I'm here to answer questions and also reach out to the TLs if you need. And we'll see if how you guys do with that, and then I'll give you some time to kind of catch up as well. So go ahead again. The so there's what we're doing. We're going to create tests to test the calculator functions. Okay. As you're doing that, a couple of questions. What's the difference between running npm test or an npx jest? npm test is going to run a script, but I think, I don't know if it's one of the defaults that you don't have to use the word run for. It's running this script right here, okay, out of the package.json. Whereas npx jest is running the jest package out of the local node modules cache. So if you had a script called test, which in our case we do, running npm test is going to do whatever this says to do, which in our case actually does execute jest, but it does some other things, and we're going to talk about what those other things are in a little bit. So when it says in the training kit, it said we did not need jest. Is using jest better than what Gabriel had in the TK? I'm not sure if you're talking about in the video. Let's see, the training kit. I admit I didn't watch the video, watched it the last time, but it's been a couple of months since I've seen it. Let's see. So obviously the training or the project that we're using is assuming jest. So there are lots of other frameworks that you can use. Jest is just one. It's not the only one. It is the one that this particular project, as well as this code that's in the training kit, is designed to use. You know, so it talks about configuring jest and using jest. And so that I'm not sure what's in the video or what he's describing there, but it's not a requirement to use it, but it is the one that we're using. So Carlos says you're using supertest. Supertest has a specific purpose and function, which we're going to go through. And I suppose you could use supertest to do everything, even the stuff that you would do with jest. But for our purposes, its main purpose and function is to provide an HTTP client and a safe environment within which you can run an Express server so that you can test endpoints. That being said, you probably could use supertest strictly without using jest, but you know, all the examples I'm going to go through will cover jest, and then we're going to cover supertest as well. So I could see where you could make the decision to just use supertest and not use jest at all. Again, it just depends on what kinds of tests you need to run and what the purpose of them is. Okay. If you get tests put together for the calculator code, let me know. Put it, maybe post it in Slack, and then we'll be able to have a look at it. By the way, we're going to cover this a little more detail later, but if you look at the challenge, one of the topics is the jest testing framework as well as the supertest module. And there's nothing really about the assignment that says you have to use jest. Actually, I guess it does. Down here it says requirements, you have to use jest and supertest. So I want to make sure that you understand how to do it. All right, a couple of examples here. We'll take a look at Joshua's first. Okay, so it looks like he's extracted these values out above any of the given tests so that they're global. And that way you get more of a dry approach, which works fine if you're if all of your tests need those. But also note, we're going to see an example of this later, that you can also change these from one test to another. So that's one thing you do have to be careful of, is make sure that if you're going to keep these out here, that that you're not modifying them at all. And of course, this is a real simple example, so you won't have that issue. But let's save this and give it a try. Okay, so we're getting some errors here. The subnum, let's see, we had 3 failed tests. So we've got under tests, subnum, multinum, and divnum all failed. Okay, so here it says, let's see. And by the way, I'm curious to know, Joshua, if this is your result as well when you ran it. Did you get the same result? It says here, calculator.subtract is not a function. Calculator.multiply is not a function. And maybe that's because I don't have the right calculator stuff. So my fault. Give me just a second here. I gave it to you guys, but I didn't put it in my own code. All right. And here I've got the wrong. See, this testing is helping, right? I've got the wrong code for this. All right, now that I've saved my code and changed it, we are getting a pass. Okay, so good job. So this looks fine. This looks exactly right. That's a good example. So let's take a peek at another one. Joshua asks if you should have used constants for the global scope. If you don't want to allow them to be changed, then that would have been better, because then it would not have been, won't be possible for any of those methods to modify them. So it's probably a good call to do that. Let's take a look at Micah's here. Okay, so here's the multiply numbers test. We'll run the test, and we get a pass. So good stuff. All right, so let's go a couple examples and hopefully how that works. And then we're going to put the calculator away now and move on to the actual project. But first, we're going to take a break. It is time for a break, so we'll do a 5-minute break, and then when we get back, we'll take a peek at this script and getting testing around our endpoints as well as our database. So let's get 5-minute timer going, and we'll catch you guys in 5 minutes. All righty. All right, so we're going to jump into looking at adding testing to our project. But as we do, I want to introduce you to another element of our testing, our test. So let me come back to this other, that's got all the different tests in it that we need. So one of the things that we can do is we can group tests together, and you can do this in a hierarchical fashion. And this is through a method that's available in Jest called describe. And the way that describe works is you give this section a name. And here we can maybe call this addition, because addition and subtraction are both just special cases of addition. And then what we can do is take these methods, these method calls, I should say, and put them inside this callback method for describe. And then down here we can do multiply. And then we can take these methods here, put them in there. And what that can help us to do is, if we look at our calculator, let's say that somebody decided to get fancy and they thought they had a better way to do addition, and then in the end they decided no, that they wanted to go back to the way it was before. Okay. And then we can run our tests. Now, something interesting happened there, and I'm wondering if anybody caught it. Test is passing, but should it be? Okay, so that's exactly right. This should be a plus and not an asterisk. Okay, just a really simple example of how somebody could break our code. But why is the test passing? I mean, do we have a bug in our code, or do we have a bug in our test? Okay, exactly. 2 plus 2 is 4, and 2 times 2 is 4. And so if we look at our tests here, both of these are going to pass, right? Because the numbers are the same. And so somebody suggested we could have more tests, and that's also true. If we were to do, for example, identity, we could say in this test, we're going to expect calculator.add 2 plus 0 to be 2. Okay, so if we save that, then run the test, then we'll get a failure. And one of the things that this describe thing can do is help us identify where the failure is more easily. Okay, because it puts the section name or the description there together with the test name. And in our small example, that's not super helpful, but when you've got hundreds or thousands of tests in a single file, each test is only testing one small thing, but you can organize them in a way that helps you find failures more easily. Okay, so obviously I've got to go back into my calculator, change that, rerun the test. And what did I do? So it says that I received not a number. What have I done here? Okay, so it should be two. I'm doing the wrong thing here. Thank you for calling that out. All right, I needed to pass in two parameters instead of one. I was doing it just passing in one number. Okay, so now you can see the passing. Good. All right, so keep that in mind. We'll use that to help us a little bit as we go through adding tests to our project. Okay. Last thing I want to talk about is test-driven development. What we've done here is you saw me write the calculator code and then write the tests to test that code. And that seems reasonable, right? It seems like the reasonable way that you would want to follow through. But with test-driven development, it's a methodology that works differently. It works backwards. And this is one of the things that I've experienced when we did in the company I'm working at now. Some time ago, we experimented with pair programming. And when we did it, we had two engineers working on the same piece of functionality. One of them would write the tests, and the other one would write the code to make the tests pass. And that's the order we had them do it in. It's a philosophy called red-green refactor. And the idea is that you want accurate tests to drive the creation of accurate code. You end up with fewer bugs in your code if you write the tests first. Once you've written the tests, if we were to go through this process and look at this calculator, if we were to block all of that code out and then run the tests, then you'll see that our calculator tests are all red. Okay, the tests are written and they're accurate, but they're not passing. Then you come in and write the code. Okay, and I've just uncommented it, but you get the idea. You write the code, and then you run the tests again, and then they're all green. Okay, so you go from red to green, and then the refactor stage is where you go through and you look to see if you can make it faster, more performant, cleaner, dry, other principles that you want, put in documentation, re-architect if you need to. And it's okay to do that because you have tests that are going to keep you safe. If you happen to do something that breaks the functionality of your code, your tests will let you know, right? So the idea is that when you first write the code, your main purpose is to make the tests pass. Don't worry about, unless you have a test that's testing performance, then you have to worry about that. And in some cases, you'll do that. But the idea is to write the tests to validate functionality, then create the functionality that makes the tests pass, and then you can go make your functionality better. And that's a pattern I found to be extremely valuable in code that I've written, and also code for teams and groups and departments that I've managed as well. All right. Okay, so what we're going to do now is go into adding tests in our project. Let me close all of these so we can start fresh. Okay. Now, one of the things that you should know about Jest is it's a testing framework that works for both backend and front end. We've been using it in the backend, which works fine. But when you're dealing with certain aspects of the Jest environment, you need to understand that it can be used both in a browser and in a node environment, and it behaves differently because its access to the JavaScript world is different in each of those environments. You have window as a jumping in point to the DOM in the browser, and in Node, it's something else entirely different in the JavaScript engine that it's running. So we need to be able to configure Jest so that it knows which environment it's running in. And the way that you do that is in this package.json. We're just going to add a top-level configuration element called Jest. And it's just an object. And one of the properties is called test environment. And we can specify what it needs to be. And in our case, we want it to be Node. And that'll be important when we're running tests against endpoints with Express. So we want to have that in place. Okay. So I'll give you a minute to get that typed into your package.json file. Okay, and then one of the things that we can do here is we'll use this test script to run our tests. And there's a number of things that are going on here. Okay, one is this command here, this cross-env command. Okay, cross-env is a node package that will take a command line parameter like this and ensure that you have an environment variable set. Okay, and we're going to talk about this db_env environment variable in just a minute and why it's important. But we want to be able to set it and ensure that it's set. One way that we can do that is we can manually set it, right? So just at the command prompt. And here I'm using a Mac. If you're using a Linux machine with a different shell, or if you're running under Windows with just a regular command prompt, the command to set an environment variable is going to be different. And in order to support environments where you've got developers using different operating systems, having a script or a shell file or command file that sets an environment variable might be a problem. If you were to, because the syntax for setting environment variables is different on different operating systems. So what this piece of code does, or this module does, is it allows you to specify with an agnostic syntax what environment variable you want to set, and it'll take care of doing it the right way for the operating system that you're running under, so you don't have to worry about it. Okay, so to get that to work, you want to yarn add cross-env. We could have added that just to our development environment as dev dependency. Actually, it did show up as a dev dependency. I think I may have already had it there. Yeah, it says it's already in dev dependency, so I already had it. In fact, I think they may have added it for us, so pull it down when I did that. So we want to make sure we have that. And when we run yarn test, it's going to first make sure that that environment variable is set. We'll look at why that's important in just a minute. And then it's going to run the jest command with the --watch command line parameter. Okay. Now what watch does is it makes jest work similar to nodemon, where jest will run, find your test files, execute them, and then keep running. And every time you make a change to a file that's not being hidden, jest will rerun the tests. Okay, so if you make a save to a file that's being tested or a save to a test file, jest will automatically rerun. So if I were to run the test script, you can see that it'll run my tests, and then it gives me this little command line parameter where if I just press the A key, it'll rerun them. Okay. If I want, I can run only failed tests. I can press enter to rerun the tests, and so forth. Okay, I can press Q to quit and so forth. So this is just a kind of a convenience thing that it sets up for us. One thing that I'll note is the --watch command line parameter only works if your code is under source control, typically with Git. I think there's one other one that it will work. I'm not familiar with it, but if you don't have Git, if you don't have this code in a repo that's being managed by Git, then you'll get an error if you try to use the --watch command. I think you have to use watch all or something like that to make it work. Just something to be aware of. It's not going to impact us because we're all running under Git. All right, so we've talked about cross-env. Let's talk about why that's important. If we take a look at our connects file, which is a configuration file, we can see that there are two different configurations that are set up in here, one called development and one called testing. And the way that they differ is in which database they point to. Okay, so both of them are pointing to SQLite 3, but the testing environment points to a test.db3 database, whereas development points to hobbits.db3. And why that's important is because as we get to writing these tests, one of the things that we'll end up doing is taking away the data or truncating the test database so that we can properly test inserting data into the database, making sure that our insert functions and methods are working properly. This is one of those cases where I said before, trying to reduce dependencies can help simplify things. It actually can be a little more complex because if you're not using the actual database, then you have to come up with a mock, right? So you have to create an interface that mocks the database, and that's extra code that you have to write. But one benefit that you get from that is that you're not testing the database. We're not interested in testing connects or SQLite 3. That code belongs to somebody else, and it's their job to test it, and we need to have confidence that it's running. And so we don't want to make it part of our testing environment. And then we're not going to have concerns about, if there are problems. But in this particular case, they've set it up so that we are using it. It's a more simple view, because in order to create a mock for this database would be a significant amount of effort. And so for our purposes, it's not really useful. But my point is that we have two different environments in here, one called development, one called testing. And one of them uses the Hobbits DB3 and the other uses using the test.db3. And we need some way to tell connects when we run our code or tests against our code, which one of these we're using, okay? And that is done in the db config file, which is under data, the data folder. What you'll see here is we're bringing in connects. We're bringing in the connects file, and we're passing the element of the config property, okay, which we're bringing in config, which is this whole object that we're exporting here, okay? So config bracket, whatever the value of environment is going to give us one of these two things if what we're passing in is development or testing as a string or as a value. We're getting that environment value either from an environment variable called db_env, or we're going to default to development, okay? So if we want to actually use this testing object out of the connects config file, we need to be able to get this to say testing. And we want to do that by setting an environment variable, because some environments may want to do development, others testing, depending on who's running it and for what purpose, right? So our purpose here is to look in the environment for this, and we can be certain that that's being set because when we run this test script, this cross-env package is setting an environment variable for us and called db_env and setting its value to testing. Okay, so hopefully you're able to follow along with this. Because we have this environment variable called testing, environment in this file, in the db_config file, is going to get that value. It's going to be testing. And then we can pass the object from our config file, which is really the connects file, the object being exported from the connects file. The property in that object that is whatever the environment is, environment variable says, which is either testing, or if it's nothing, it could be, we'll default to development. Right, so that ensures that we're passing this object into connects, which is going to cause connects to connect to this database file. Okay, so hopefully that makes sense. That's where this this thing comes into play, because we want this environment variable to be set, but we want to do it in a way that accounts for multiple operating systems, and that's what this thing does for us. And then in our db config, we're pulling it out of the environment and passing it into connects. Okay. All right, so now you'll notice that in our server file, let me close these down. If we open our server file, you'll notice that we're getting an express object and creating a server from it. but we're not doing a listen in here. We're doing that in the index file. Okay, so we're exporting the server from the server file, and that allows us to use it in the index file right here. We can bring it in and use it to execute a listen. The challenge that we'll have is if we write tests against our Express endpoints, and we have more than one test, or we have tests in different files, we have to figure out how to get an instance of Express, because the way that just will work is it'll execute these tests in parallel, and they each will want to have access to their own Express environment. And if the only way to get Express listening is part of this server file, then every test that runs is going to start listening on the same port, right? So the second test that runs will complain because there's already another test running that has Express running listening on that port. So this is where supertest comes in. Okay, so what supertest is going to do for us is create a situation where when we're testing endpoints for Express, we can have multiple tests, and each one of them can test a different endpoint, and it can do them at the same time. Each one will have its own instance of Express listening on a different port, so they're not going to conflict with each other at all. And what supertest will do is take our server object and start it to listening on what's known as an ephemeral port. It's one of the temporary TCP ports that's not well known and not being used on the server. And so if you've got 4 different tests, each one will execute with a version or an instance of Express listening on a different port. And supertest also has methods that we can use to make requests into Express, into our endpoints running in Express. And it will know to direct those requests to the right port because it's all part of one environment. Okay, so for every test that runs, supertest will launch its own instance of Express listening on a unique port, and when that test makes a request, it'll go to that instance of Express. And when another test runs, it'll get its own instance of Express listening on a different port, and any requests to Express that we make in that test will go to that instance, and supertest is what manages all of that for us. That's why I said earlier that just runs tests, supertest does as well, but the main focus and purpose of supertest is to allow us to do 2 things. Number one, have simultaneous or parallel instances of an HTTP server like Express listening on different ports, and it manages that for us. And number 2, it also provides a collection of API calls or library calls that mimic HTTP requests like you would do from Postman, right? So all of our testing to this point has been either with the browser where we're issuing GET requests, I should say GET requests, or from Postman where we could do GET, delete, put, or post. And what supertest allows us to do is to mimic an HTTP client by making those same HTTP requests to its own little instance of Express running listening on a unique port. So we'll get a chance to see how that gets set up here as we go. And that is the main purpose for supertest and why we're using it. Okay, so the first thing we want to do is let's add some tests for our server. Okay, so right now we've got this thing in here, and I'm actually just to keep these out of the way, I'm going to rename that folder by taking one of the underscores off, and I'll rename test file by changing its name. And I'll come back and change these back when I go to upload it, but that way we can just put out of our, we're only dealing with the server and with the Hobbits data model, which we'll come back to in a minute. Okay, so right now, what we did. Okay. I'm not sure why it didn't pick up our server test. Oh, I think it's because when we're watching it, it ignores empty files, which is fine. All right, so in our hobbits file is not empty. Now it says there's no test found, which is what we wanted. All right, so here in our server test file, we're going to do a couple of different things. Of course, we want to bring in our server object because that is the thing that we're testing, right? So that's going to be in the same folder. And then what we want to bring in is super test. Okay, so it's a kind of a convention to call it request, or some people will give it other names. It doesn't really matter what you call it. I'm going to call it request. And we're just going to bring in super test. Okay. Now that I have these, I'm going to create myself a describe section. Okay, for server.js. And the first thing I want to test is I want to test that my environment is the testing environment. Okay, so this is how you would do that. Okay, so in our callback, we're going to expect that process.env.db is testing. Okay, we save that. Oh, you know what? I haven't added super test, so let me do that. I need to yarn add super test. Okay, so now my one test in my server spec is passing, and what it's testing is to make sure that we're in the test environment. Okay. So what we're going to do next is, and at this point, we're not actually using supertest. Okay, there's nothing in here that's using supertest. I'm just doing a regular test. Jest is running it, and what we want to do next is we're going to check endpoints in our server to confirm things about it. So, for example, we could see that the get to root is supposed to return a JSON object that looks like this, and is supposed to return a 200. Okay, so what we could do here is put in a different section that's just all about this, because we've got a few things that we want to test about it. And remember, one of the key principles that we want to follow is that each test should only test one thing, right? And I'm going to switch over to the alias format and use it instead of test. Okay. Okay, so you can see kind of how that works together. It should return 200 okay. It just reads a little more clearly and makes it really clear exactly what it's supposed to do. Okay, so the first thing we want to check is if it's returning a 200. And we'll do a request. We're going to call this request method that's coming from supertest. And what we're passing it into it is the server that comes from server.js, right? So server is an instance of Express that we're exporting. And by passing it into request, that allows request to start this server listening on whatever port it wants to listen on. It'll choose, right? It's not one that we need to know. Because in addition to starting the server, the next thing it's going to do, because we're going to tell it to, is it's going to issue an HTTP GET to that URL, whatever URL we put into it, okay? So this starts the server listening on whatever port, and then this will cause Supertest to issue an HTTP GET against that server on whatever port it started it listening on. Now, this is a promise-based API, so we know that what we're going to get back is a promise. So we need to call .then to handle the response or the result. Okay, and we're going to pass that in. And in fact, let me format this a little nicer. Okay, so when we get the response, then this is where we could say we expect the response.status to be 200. Okay. All right. So we're going to save that, and we'll see that it passes. And maybe to do just a quick sanity check, what we can do is say we expect it to be 500. Now we know that that's not correct, because if we look here, it should come back as a 200. What this should do for us is it should cause this test to fail. Right, so I'm going to save that, it'll rerun it. It says that it passed. Okay, what do you think could be the problem here? Why do you think this test passed, even though we're telling it that we're expecting a result that's different than what's coming back? Okay, keep in mind that this is returning a promise. Okay, one suggestion is to set a variable to response.status. That's not going to help. So Micah says his failed. I'd like to see your code, Micah, if you could post it. Okay, so Corey says we should await the promise. So I like that because I am going to switch over to an async await syntax here in a little bit. I'll just give you an example of how that works. But that actually wouldn't help us. Actually, no, it would help us, Corey. You're actually right. That would help us, but we're going to do it in a little bit of a different way here first, and then we'll get to that syntax. So you're on the right track, but it doesn't quite explain the reason why. Okay, so I'm looking at Micah's code. Micah, when you say you expect the status to be 200, does it pass? And if you set it to 500, it fails. Yeah, that's I'd like to dig into that. I don't know how much time it would take to get to the bottom of it, because it should pass. And the reason why it should pass is because, and it's possible that maybe it has to do with the speed of your machine. I don't know if you're running in a rocket or not. But what's happening here is that this is returning a promise, and the promise itself is not a negative result. Okay, the promise is not the value. What this is going to do here is return a value that indicates failure. Okay, but what's happening is we're returning the promise before this actually gets to occur, and that's the reason why it's succeeding. So in order to prevent that, what we want to do is actually put return in front of request. If I do that and save it, then I should get a failure. It says it was expecting 500 and it received 200. Okay. So this is the idea, is that this signals to Supertest that it needs to wait for the promise to resolve. When we return the promise, it knows that it's getting a promise, and it will wait for it to resolve before it completes. So another way that we could do that is we could use the async await syntax, right? So here we could say that we want to get a result from the server like this. And then once we get the result, we can say that we expect status of the result to be 200. It's a little cleaner to me, and as a sanity check, we'll make it 500. Save it, it should fail, which it does. Change it back to 200, then it should succeed. Okay. There's also a way to test for failure, failing tests if you want to write them. So that's another technique that you can use. But Corey was on the right track when you say we need to await the promise. I think I understand the way that you described that now is exactly correct. Here we're using the await keyword, but previously we needed to indicate to supertest that it should wait for the promise to resolve. And that's the way we did that, was by returning the promise itself. Okay. Yeah, Micah, you might, I don't know, your clock might be, I don't know if you've overclocked your machine or something, because it could be resolving before it actually returns, which could be part of the issue. Okay, so Logan, if you're getting that, it's because you didn't put async. So the error that it says you put in, you cannot use the keyword await outside of an async function. You need to decorate your arrow function with the async keyword. You can't use it await unless it's inside an async function. So you have to declare your callback function here to be async, and then you can use the await keyword there. Okay. Yeah, not a problem. Easy to miss. I've missed it before as well. Just glad that the JavaScript environment is willing to keep us on the straight and narrow. All right, I'll give you guys a minute or two to get caught up. Those of you that are still coding, I'll leave this code up. I'm just going to kind of talk through it again. Here we're bringing in our server object, which is not being started. It's just a server object from Express. Before we export it, we're also configuring some middleware and some handlers here. Okay, so we set those up, and then when we return it, it's not actually listening. The index file, when it gets it, will use it to start it listening. In our case, it tests. When we get it, we're ultimately passing it into an instance of supertest, which will also start it to listen, but it'll start it on a random port. It's not really random, but you get the idea. And that way, if we have multiple tests that are executing against the same Express code, each one of them will get their own instance of Express listening on a unique port. And that's what supertest is for. In addition, supertest provides us with a number of variable or methods that map onto the HTTP request verbs, like get, put, post, and so forth. In fact, if we take a quick peek at the documentation for supertest on npm.js, and you get some example of the different kinds of things you can do. Not only can you call a method, but you can set headers, and then you could do multiple expects, looking for content type and so forth. Note that these expect method calls are part of the supertest module and not jest, right? And this is where I think what Gabriel was trying to point out is that there's a lot of similarities to these two different testing frameworks, but they do have different purposes. Supertest in particular, as it says, that the motivation of this module is to provide a high-level abstraction for testing HTTP. So if you're not testing HTTP, you really wouldn't have a purpose for using it. So what you need is a client, kind of like Axios, but with some differences, and a way for you to have multiple instances of that HTTP server running so that you can make those client calls into it, into those individual instances. Okay. All right. So next, what we're going to do, in addition to testing the return status, we can test the content type. Okay, so if we look again at server, not only do we expect the 200, but we expect the body, sorry, this is the wrong one. We expect the body to be in the JSON format. Okay, so that's another test that we can execute. Say it should be JSON. Okay, so in here, we're going to do the same thing where we get the result. And then we expect the type of that result. And knowing what things you could use here is going to be a function of digging into the documentation. I'm just giving you some examples here tonight. We're not going to do an exhaustive treatise on what properties there are on the response object. They're the ones that you would expect to find, but in some cases the naming might be different, or how you can access them might be different. So you're going to want to check in on the documentation for super tests to learn that. But here I know that we can use our response.type, and we're expecting it to be a string that is application slash JSON. Okay, so to kind of give you an idea of what's happening there, we'll quit that and start the server up. It's listening on port 5000, and then we'll make that simple request from Postman and look at the header that comes back that it's doing a search or a look at. So we're going to do a get on localhost 5000, just slash. And we get a 200 with this data back. And if we look at the headers that came back, one of them is content type, and this is the value. Now there's some other stuff that comes back with this header. One of the things that super test will do for us is, for example, create a property called type and then give us just the type. There may be other properties that we can use to get other things like this, where we've got compound values inside headers. So it's parsing this for us and allowing us to check for the type with or without the char set. Okay, because if it came back just saying application/JSON, that would be acceptable as far as we're only testing the type. So super test will take care of all of that for us. Okay. Start our testing server back up. Okay, so here we're testing to ensure that it's valid JSON. And then the next thing we might want to test is the actual body. Okay, so here we could say it should return the right object. Okay, as I'm going through this, there's a couple of questions that have come in. Logan says, I'm getting an error. We talked about that. Joshua says, I passed JSON in my to-be, and it says expected brackets and got whatever was correct. We'll give me a chance to go through this, and you'll see what that should look like. Is you're not going to want to use to-be. It's actually a different method called to-equal. Okay. We'll go over that here in just a second. And Logan says, can you test for both using an ampersand, the logical and? And the answer is yes, but I want to re-emphasize, because it's really important, the principle that you want your tests to test only one thing. It might seem wasteful, but it's really, really important as a pattern and as a process, because if you get into the habit of cramming multiple things into a single test, your tests, you'll be tempted to, and if you're willing to do it, you won't have a reason not to make your tests more and more elaborate, which means that you could more easily introduce bugs into your tests. Okay, so you want to keep them extremely simple. My recommendation would be not to test for both in a single test. Go ahead and code multiple tests. Okay, so to test the actual object that gets returned, we're going to get the response request. And then we're going to expect the body to equal an object like this. Okay, so if we were to look at the documentation, oh, this is the wrong thing. It's actually just that one. Here, we've got this here. See if you can find, there we go. Two equal, here we go. Okay, so here it talks about the difference between 2 equal and 2b, and you can kind of dig into that and try to understand, start to understand how they work differently. Okay. So again, here we've got this test put in place, and if I were to save it, then my tests will re-execute, and you can see now we have 4 different tests that are passing. All right. What we're going to do is take, let's see, another couple of questions. Does that get into CS theory and anti-patterns? Joshua, let me invite you to clarify that question, maybe add a little more detail, and when we get back, I'll answer it. I'm happy to chat with you on the sidebar. Oh, sorry. So you're talking about my answer to Logan's question, which is making the tests simple. It's not really CS theory, but it is an anti-pattern for sure, because again, since we're using code to test code, and our pattern for testing code is to write code to test code, you could be, you know, where do you stop, right? So we can write, we've got our production code, and then we write test code to test our production code, but then do we need to write test code to validate that our test code is accurate, right? It gets silly. There's no reason to do that. The only way that we can really have high confidence that our testing code is accurate is to have a habit and a pattern of making our tests really, really simple. So we don't need, you know, and you might say you could do that with your production code to the extent that you can, you should, but you'll probably find that you'll have architectural patterns that will be difficult to implement that way, and other libraries that are hard to use. It might not be as efficient as you need it to be in terms of your productivity. And so you're going to want a different level of complexity in your production code, but in your testing code, you want it to be really, especially when you're talking about unit tests, you want it to be really, really simple, okay? And that's just so that you have less of a chance to introduce bugs. All right, so let's take a 3-minute break because we've got one last topic we need to cover before we end. We've got about 20 minutes left. It should be enough time, but just to make sure, if you gotta take a bio break, go quick. We'll be back in about 3 minutes. All right, guys. On to the finale. Before we do that, let me just do a quick Slido poll and get an indication of how you guys are doing. Let's see. We'll make it ready to move on is the question. If you've got unanswered questions and you feel like you know, you've fallen behind and you don't want to move on yet, then let's see, let's save that and then start it. Then let me know in the Slido so that I get an idea. And if you don't answer, I'll assume you're fine. But if you feel like you're ready to go to the finale and talk about how to test database stuff, we can finish off with that. But I do want to make sure that everyone's feeling caught up. There's a question in Slack. Okay, Caleb, so you're saying that your process.env.db_end test is failing, where it's expecting that variable to be the string testing. And the question I would ask is if that is because you're running the test by executing just from the command line, or if you're executing the test script from package.json. Because the script, if you'll notice in package.json, is where that environment variable gets set to the right value. Right, this command right here is going to set that environment variable for you. So if you're not executing this script and instead you're just running just from the command line, it's not going to be setting that environment variable. Yeah, and as Joshua said, if you run yarn test, it'll run that script. I think you could do npm test as well. Okay. A whopping 6 of you responded, and everyone said yes, so I'm going to go ahead and move on. Thank you for those that responded to the poll. Okay, so what we're going to do is we're going to actually kind of dive into this test-driven design aspect a little bit as we get to the end here. So you'll get a chance to see a little bit of that at play. So what we're going to do first is we'll open up, let me close down all of the server stuff here. Okay, and we've got our Hobbits model spec open, and we'll open up the Hobbits model as well. And in the model spec, we're going to do a test around this insert method here, okay? So we want to test that it's properly inserting data when we call it, okay? So there's 2 things that we're going to need to do this. One is we need to have access to the Hobbits model, right? We'll just call it Hobbits. And the model file, if you remember, is just a JavaScript that's wrapping our connects calls, right? So we'll call this, it's in the same directory as the test over here in our folder. And it's called Hobbits model. It's called Hobbits model.js. And when we look at that, we could see that it's exporting all of these methods. Okay, and we're going to need that in order to execute them so we can test them. The other thing we're going to do is we're going to get an actual instance of connects. Okay, and the way that we do that, if you remember, is we need to bring in our config file. This is what gives us access to connects. And there's a reason why we're going to do that. We're going to use the Hobbits model to do an insert on the database. We could potentially use the Hobbits model to read the database to validate that the insert was successful. But the problem with that is that that's the thing we're trying to test. Okay, so this is where we want to get outside. We want to do this out of band. We want to use a different method to validate it than the method we're using to actually do the thing. Otherwise, you know, there could be errors and problems there. In this case here, what we're doing is using connects directly. It might be more complicated depending on what it is you need to do, but that's the price you need to pay in order to make sure your test is not being impacted by testing more than one thing. If you have a test that calls the Hobbits model to do an insert and then calls the Hobbits model to do the check, in reality, that test is testing two different things. But you're really only going to be looking for validation from one of them, and that's really not the pattern that you want to follow. So in our case, we're going to use the Hobbits model. This is what we're actually testing. And we're going to use a connects instance to actually validate that by looking in the database directly that our data was inserted. Okay, we're going to do a describe, and we'll call this the Hobbits model. Our callback method is going to have, we'll do another describe in here just for testing insert methods. Okay. So again, this is just a pattern of organizing your tests. With so few tests, it might seem pointless, but when you get, again, to having hundreds or thousands of tests in a single file, this could be really, really helpful and important. Okay, so that's why I'm demonstrating it for you. Oops, you keep auto-completing the wrong thing. Okay, so in this case, we'll say it should insert the Hobbit. Actually, not the Hobbit, but because they're fictional creatures and you can't put them in a database, but you get the idea. Okay, and what we want to do here is call hobbits.insert. That's the name of a hobbit, and that's the name of another hobbit. Okay, we're going to insert two different hobbits, and then what we're going to do is read them back from the database using our connects object. Okay. And what we expect is that the array comes back from connects as a length of 2. Okay, so once we insert them into the database, we should have 2 things in it, and we're going to read back from the database to validate that that's the case. Okay, so if I save this, it's executing my server and my hobbits. And what did I do here? The problem here is that this is a promise-based API, and what I was getting back from this was a promise and not the array, because I need to wait for the promise to resolve. So that's why I'm getting that error. So what it's saying is that the thing that goes into this, in order to call this method, this thing needs to have a length property. So right, it's saying that received value must have a length property whose value must be a number. But without the await keyword here, what I was getting back was the actual promise object, which doesn't have a length property. But by putting await in, when the promise resolves, what I get back is an array, which does have a length property. Okay, so saving that should fix my problem. It says that it expected 2, but it got 0. Okay, so if we start to kind of think about that and wonder why that might be the case, we're going to want to go look at our code. So what we're testing is this insert method on the Hobbits model. So if we come over here and look at it, we'll see that our insert method is not actually doing anything. All right, so this is red-green refactor. We wrote our test. It's testing the right thing. It's failing. Now we need to make it pass. Okay. So what we're going to do here is, let's see, we'll add a line here. We're going to need to actually do the insert. But once we do the insert, we want to get the ID back so we can retrieve the object and return it. That's what this code's supposed to do. We can write additional tests to validate that that's the case, we'll go ahead and write our code here. So we're gonna, I guess I need to put an equal sign in there. We'll await DB on the hobbits table, and we're going to insert the hobbit object, which is coming in as our property here, our parameter. Okay. And then what we want to return is the hobbits table. We're going to do a query where we get the ID. That's going to return an array. Even if it's a one-item array, we need to get the first object from it, okay? Now, this return isn't really going to impact our test, but this is the thing that's going to impact our test because it's actually doing an insert now, right? So if I were to save this and our test reruns, then we can see it passes, okay? So the stuff in our hobbit thing is passing now. Okay, so Josh was asking, is this anything going to work if everything returns null? And the answer is no. Again, we're doing the red-green refactor model, right? So you've kind of caught on to the idea here, is that we really haven't implemented anything. We want to write the tests first, and then come back through and make them pass as we did here. Okay, so I'll give you a minute or two to kind of get caught up with this method and get your tests pass. We'll see if there's any additional questions. Nothing so far. Okay. So again, pretty straightforward. All we're doing is we're doing an await here because it's a promise-based API and connects into the hobbits table. We're inserting the hobbit that's being passed in. We get the ID back, and we use that to retrieve that thing that we just inserted and return it. That's the pattern we've used with all of our database methods so far. And that's what's allowing this thing to pass, okay? Next thing we want to do is we want to test this portion of it, that it's returning the right thing, right? So we're going to do another test here for insert. We could say it to return the hobbit that's inserted. And in here, we're going to create a variable called hobbit. And on our model, we're going to call hobbits.insert. And then what we expect after that happens is that the name property on that thing that comes back is Gaffer, okay? And then what we want to do is we'll just do it again with Sam. Okay, now if we save this, this needs to be an async function. It's complaining here because the await, it says it cannot use the keyword await outside of an async function because I forgot to put that on there. So we'll save that. Now I've got a syntax problem because I'm using the let keyword again. And I don't want to do that because you can only declare a variable once. You can see here it's saying identifier hobbit has already been declared because I was doing a let again there. So we'll save it. That should fix that error. Well, now we've got a different problem. This problem is a failed test. Okay, it's under the hobbits model section under insert. Of course, this is the only section that we have. And it says that this test should insert the Hobbit into the DB. And we're expecting the length to be 2, but what we got back was 4. Okay. Well, obviously the reason for that is because every time we run it, it adds more records to the table, right? And so what we want to do is use a method for cleaning up our table before the tests run. And this is where it's important to specify that we're running in a test environment, because again, if you go back to the connects file, the testing environment is working against this database. And what we want to be able to do here is empty that database before these tests are run. And we may not want to do that against our development database or against any other database. So it's only the testing database that we want to do that against. So to do that, you're going to call a method that's part of Jest. It's called before each. And because we're going to need to call a promise API to it, so we're going to make our callback function be async. And all we're going to do is on the, using our connects database object on the Hobbits table, we're going to truncate it. Okay. So now everything should pass. We're getting no failed tests. Everything is passing. Okay. Yeah, Mike is saying that's why he's getting a length of 56 back. Okay. All right, so that's all the content that I have tonight. If Josh, you're saying yours is failing, post your code and let's take a peek at it. We'll take another couple of extra minutes to see if we can figure that out. If anybody else is having problems, I'm happy to stick around and help out with that. But in terms of material, this is all that we have to go through tonight. So we've talked about the Jest framework. We've talked about a lot about testing and testing philosophy in general, different kinds of tests. And tonight we've focused on unit tests. We did the calculator exercise. We talked about describe, test-driven development, the Jest environment. We talked about the utility in package JSON called cross-env, which is a cross-platform environment variable setter. Not really germane to what we're doing, except for that it ensures that tests can be run on other environments, even if it's on a different operating system, where we depend on an environment variable. And we talked about the role of the environment variable, in our case, for ensuring that we're running against the correct database. We've talked about supertest and its role in allowing us to test endpoints of an HTTP server simultaneously with multiples of them, as well as providing an interface for issuing HTTP requests as a client. And then we looked at a couple of different tests for testing the return value of headers and so forth on endpoints. And then in testing the database, we took a look at using connects directly to validate our data model, which is using connects, but it's really the data model itself that we're wanting to test. And then lastly, we took a look at using this before each, and that's one of a number of before different methods that you can call that can control both setup and tear down. There's also after methods you can call that to tear down setup that you have to do to get your tests mocked properly or executing properly. And then just to reiterate, you know, the whole red-green refactor, if we take a peek at the challenge, the requirement here is that you write your tests before you write your production code. Okay, so you're going to want to follow that pattern, and then it's a bit difficult in terms of thinking, because you really have to think about what it's supposed to do when it's done. You haven't written any code yet. You've got to write tests against it, and you'll find yourself, I think, enlightened by the kind of thinking that has to go into writing tests before and how it makes writing the code and writing it to be fairly bug-free simple. So hopefully you'll enjoy that. So with that, I'm not going to drop off just yet. I just want to say again, I've really enjoyed spending these 6 weeks with you guys, and I hope that the build sprint that you're going into is going to be successful for you, that you guys enjoy the holidays. And most importantly, I just want you to know I really admire you for the effort that you're putting into what for many of you is a brand new career. I think your energy and your focus is admirable and is inspiring to me. So I appreciate all the hard work that you're doing and the patience that you have with me and with others that are trying our best to help you be prepared for that. So feel free to hit me up on LinkedIn, Sean Kirkby, or I think Sean Kirkby. I'm happy to make a connection if if our paths cross again in the future, which it's very possible that they will. Let me know that you were in my class, and we can reminisce about the good old days. So let me take a quick peek at, okay, so Joshua, yours is just a syntax thing. You got it, okay. All right, and thank you guys for the great comments as well. And with that, we'll sign off. And thank you, Sasha, for everything you've done to support this classes we've gone through. You've done a fantastic job, and I really appreciate that. And to all the team leads, you guys are really fantastic as well. So have a great night, a great holidays, and we'll catch you guys on the flip. Bye, guys.